wearing blue jeans? I don't think I've ever seen you wear blue jeans before.
Yeah, this is for cheer and dance. We have to wear these painted jeans.
Is this the first time you've worn blue jeans in the last year?
I wore jeans in the first day of school.
I was kidding.
That's about it, though.
If I turn in the page 10 that I've missed, can I get half of the points back?
Half of the points. You get half of the points back that you missed the first time.
Oh, awesome.
Is this your first page, or what happened?
Look, this staple tore through the paper. So I went to grab 10 and I didn't have the other one labeled because they were stapled together.
I understand.
And here's number 20.
Oh, yeah, sorry.
So I was here yesterday. What would the policy be for number 20 that took us out?
You get an extra day.
So next Monday?
Good morning, Batesville High School. Today
Yes,
is
just turn it
Friday.
in Google Classroom.
September 20th, 2024.
Mr. Townsend, did you get my email of the assignment?
Did I get an email of your assignment?
No, email of like questions about assignment.
I did,
Uh,
but I don't check my email that late. I will never respond that late.
oh no, I didn't expect you to. I was wondering if this morning.
Yeah, I'm just gonna take like the incomplete thing because I
don't want to do the problems just based off the key, not in them.
Okay. I understand. You can still get half your points back as long as you finish it before the test.
Yeah, that's what I'm gonna do.
Okay.
But I didn't want to just copy keys, say, like I did.
All right, good morning, guys. If you did not finish up the circuit in last class, this would be your last chance to get full points for that. And the book assignments you could have turned in Google Classroom, but if you did not, you should give me what you've got. Remember, even if you forgot to finish it, you should go ahead and give me what you got. Take that out of credit, because then that way when you finish it and turn it back in before the test, you'll end up with more points overall. So I need that in the next 60 seconds or so. All right, today we are going to look at the last big topic that we will do in Unit 2. So this is the last of the derivative types by hand, called chain rule. And if I had to pick out one single lesson all of first semester that's going to be the most important to you, it's probably chain rule. The impact of chain rule is about the same as the impact of the unit circle in pre-calculus. So the good news is it's not a different type of differentiation. We're going to add on to what we already know. We've got the derivatives we have memorized, like e to the x. We've got power rule. We've got product rule. We've got quotient rule. And now we will have chain rule. So we're still going to do the same stuff that we've been doing, power rule or product rule or quotient rule or some combination of those, along with some combination of what we need to have memorized. But then after that, we have to ask ourselves about the chain rule. So both handouts 23 and 24, are those two numbered correctly? For some reason I was thinking they said 22 on them.
They are.
Okay. All right, so both of these handouts are pretty short. You honestly only need to see a couple of examples to know what you're supposed to do for chain rule. It just takes a lot of practice to actually train your brain to think about it each and every single time. Okay, so on this one, so first off, chain rule is going to be needed anytime you want to take the derivative of a composite function. Composite functions anytime you have a function plugged into another function. So to show you the need for this, and every question you have done before has been correct, all of those have been rigged though where they didn't need chain rule. So if I had asked you to take the derivative of this, I would expect most of you guys to say, okay, I'll bring the power down and I will lower the power by 1. And you might think that the answer is 2x cubed, but it is not 2x cubed. To prove to you it's not 2x cubed, notice that you could take x to the third and square it, rewrite it as x to the sixth, and then you could do the power rule, and that would be fine. So notice, same question, but if you just only strictly try to do power rule, then you're not going to get the correct answer. So the first challenge in these questions is you're going to have to think about what's the inner part of the function and the outer part of the function. So the inner part of the function, here's how you should actually approach this, because I know you can rewrite this one with algebra and exponent rules, but you can't always do that. So the outer part to me is we've got something being squared, bless you. I'm just going to use u instead of x because I don't want y'all to think I'm talking about this same x. The outer part, there's something being squared, and the something, the inside part, is the x cubed. So the chain rule process, the way you need to phrase this in your head and say it in your head 50 times until you just do it instinctively, is you want to start by taking the derivative of the outer part. So bring the power down, lower the power by 1, but with the inner part plugged in. Then you need to take, so second step, you need to take the derivative of the inner part, 3x squared, and then finally piece those together, the derivative of the outer part with the inner part plugged in, which I have as 2 times x cubed, times the derivative of the inner part, which was 3x squared. All of this makes up the real derivative. 2 times 3 gives you 6. X to the third times x squared gives you x to the fifth. So notice, it's the same question as this one. I know this one is easier to do by just doing the exponent rules. I'm just trying to show you the process. We take the derivative of the big outer picture, probably power rule. I guess it could be product or quotient rule. But I had something being squared, so I just did like the regular old power rule there. I brought the power down, lowered the power by 1. But you need to leave the inside part plugged in. So inside part was x squared, so I left it x squared. You also have to take the derivative of the inside part and then multiply these two together. Multiplying those two together is how you get the ultimate derivative. Okay, so to say this again, and then I have it typed up for you on the next page. If I had this function, y equals e to the 4x, to me, what I say is the outer part. I'm just thinking of the big picture, the big function. I've got e to some power. You need to take the derivative. Oh, I'm sorry. The outer part, yeah, is e to some power, and that inside thing that's getting plugged into that is 4x. I'm trying to keep this color coordinated to help you see that. So chain rule says take the derivative of the big outside part. The derivative of e to something is e to something. I know I've been saying the derivative of e to the x is e to the x because that's true, but it's really the derivative of e to something is going to be e to the something, but with the inner part plugged in. So leave the inner part there. Then take the derivative of the inner part, and your full derivative comes from the derivative of the outer part with the inner part plugged in times the derivative of the inner part. So we end up with 4 times e to the 4x. Now again, you have not had to deal with this up to this point because every question in those circuits, every question in that long book assignment, all of them always had the derivative of the inside part was always 1, and multiplying by 1 doesn't change anything. So you haven't been doing it wrong, you have just been avoiding certain functions. Okay, so right here, this is basically what I just said with the first example. Here's x to the third squared, so you need to think about what's being plugged inside, x to the third, and what's it getting plugged into? It's being plugged into something squared. And so the derivative, the chain rule says take the derivative of the outside part with the inside part plugged in times the derivative of the inside part, and so that's the same thing we did on the other page. And then here's the same thing we did with e to the 4x if you want to look back at that. Think about what's being plugged in to the e to something. The something is the inner part. Take the derivative of the outer function with the inner function plugged in, multiply it by the derivative of the inner function, and those two multiplied together give you your full derivative. Now, the way I'm saying it, once we start doing more questions and not trying to fill out the blanks here, I think it'll click a little bit quicker. But sometimes it's nice to look at it like this. This is saying this, I know it's kind of intimidating looking, but this is saying the same thing. This is saying take the derivative of the outside part with the inner part plugged in times the derivative of the inner part. Derivative of the outside part with the inside part plugged in times the derivative of the inside part. Sometimes you really want to think of it in this format. So as soon as we finish with these two handouts, again, they won't take too long today, but I have 5 Khan Academy assignments for you. 3 of them are in chain rule. 1 of them is just trying to pick out what would be the inner and outer function, so I would suggest you do that one first. 1 of them asks you to use, try the chain rule with the table, and then that's where this is probably going to shine. This is kind of telling you how to, what information to extract from the table, so you'll want to look back at that today. Okay, let's look at a couple quick examples here that I will do all of these for you, and then on the next handout I will ask for your participation so I can see what you're getting and what you're not getting. So when I look at this function here, this is not just x to the 7th, I just use regular power rule. But if I look at the big function, I've got something raised to the 7th power. So the first part of chain rule, it says take the derivative of this, of just a big picture. So bring the 7 down, lower the power by 1, and when you're taking the derivative of the outside part, you leave the inside part plugged in. You don't change any of that inside part. So that's basically what you've been doing. It's just that this looks messier. The only additional step you have to do is you have to ask yourself, what is the derivative of the inside? If the derivative of the inside is 1, then you're done. But if the derivative of the inside is not 1, if it's 3 minus 10x, you have to multiply that in. All of that becomes the derivative. So as I do all of these examples, I will try to emphasize the inside part by scribbling under it, and I will do the chain rule derivative in purples to help you try to see that.
Do we need to simplify it or not right now?
Something like this, probably not. I don't think that you could do much with this. I guess you could force multiply this by itself 6 times, but that's not going to help us out any. So, okay, so number 7, let's first rewrite this. This is cube root of something squared, so let's just call it to the 2/3. So, thinking big picture, I'm thinking power rule. I'm going to bring the 2/3 down. I'm going to lower the power by 1 and move it to the denominator. So there's the derivative of the outside with the inside still plugged in. In this case, the inside is x squared minus 1. The only additional, again, it looks more complicated, but all I did was power rule. Brought the power down 2/3, lowered the power by 1, moved it down here. Chain rule then says if the derivative of this inside stuff is not 1, you have to multiply this by the derivative of the inside, which would be 2x.
Wouldn't it be negative 1/3?
Since I moved it to the denominator now.
Okay.
So the derivative of the inside was 2x, so multiply by 2x. So yeah, this one we'd probably simplify. We'd probably just call this 4x. 2 times 2x would be 4x. Okay, so number 8, what's the derivative of sine of something? Okay, cosine of something. Don't just say x anymore, say the something. Sine something is cosine something. And then chain rule just says, think about the inside thing and multiply by its derivative. The inside is 2x. The derivative of the inside is 2. Multiplying by 2, now that's the correct derivative. Putting a 2 next to x makes the rate twice as fast. It's going to make the derivative twice as fast. Okay, I know we came up with this one.
5 to 2 cosine 2x.
Yeah, same thing. The order of multiplication doesn't matter. So, okay, this one came up yesterday, and a lot of you guys took the shortcut. So that means that you have started memorizing these. What's the derivative of tangent something? Get secant squared of that something. So there's the derivative of the outside with the inside plugged in. And then chain rule says times take the derivative of the inside, which would be 2x. So again, it's not that chain rule is a different type of differentiation. It's just an extra step on top of what we've already been doing. Chain rule is still going to be power rule, product rule, or quotient rule. 99% of the time, power rule. Okay, so now let's slide over to the other handout and practice a couple more as a group so I can see if you're headed in the right direction at least. Okay, so for question 1, what should the first part of my derivative say?
And then the things in parentheses to the third power.
Okay, very good. So he just did the derivative as one big picture. He brought the 4 down, lowered the power by 1. Somebody else tell me, is there anything else I need here? Okay, multiply by the derivative of the inside, which would be another 12x plus 7. Once again, I'm going to put all the chain rule. I'll put all the chain rule in red on this assignment. All of this makes up the derivative. Now remember, when we started class, I said it's not that chain rule is hard, but you do have to train yourself, because if you don't think about chain rule, then I mean you can miss 5 questions in a row. Okay, somebody else, what would be the first step in taking the derivative of this mess? How do you take the derivative of something to the -2? What rule should we use? Good. So use the same power rule. Bring the power down. Lower the power by 1. And then the only, I mean, it's messier when I say bring the power down, lower the power by 1. What you're raising it to is a much bigger mess. And also, I didn't even copy it down right. But the only additional step is you've got to train your brain to then come back and multiply by the derivative of the inside, which would be 8x minus 3. And we are not going to bother with simplifying at all on these today. All right, number 3. Also, let me say this real quick, because I don't know if this is, I feel like this has probably come up, but no one has strictly asked it. Sometimes when we talk about derivatives, we use these tick marks. So like the derivative of y is y prime, the derivative of f of x is f prime of x. I know you're used to seeing that, but sometimes we also say derivative is like dy dx. Has anything we've done look like that yet? Okay, that's the same thing. This means take the derivative of y, and it's got x's in it. This also means take the derivative of y. It's 2 different types of notations, 2 different mathematicians. This is kind of convenient sometimes, but sometimes this is nice too, so we use them interchangeably. Okay, so number 3 is going to start off the same way. You're going to do the power rule. You're going to bring the 1/3 down. You're going to lower the power by 1. Again, I'm not going to worry about any simplifying here. We're just focused on the chain rule. And then the chain rule says come back and multiply by what? Multiply by -8, the derivative of the inside. All of that makes up the derivative. Again, obviously I'd probably put the -8 up here, but whatever. Okay, what about the derivative of cosecant something?
We use our shortcut first.
I'm sorry?
We use our shortcut first.
What's your shortcut?
Let's go back to it.
Very good. So the derivative of cosecant something is negative cosecant something, cotangent something. The something just happens to be 7w times the derivative of the inside, which would be 7. Okay. Actually, I would like you to try question 5 first before we talk about it. I want to see if you can figure out what to do with that, since it looks a little bit different. If you're wrong, you can erase it. It's not a big deal. But go ahead and write down what you think you should do for this one. So this is why I was trying to get you to, I am going to ask you to do one Khan Academy that forces you to think about the inner and outer. When I look at this, it's -2 sine of all of this stuff. So the derivative of 2 sine of some stuff would be 2 cosine of some stuff. I know this stuff is a little more complex, that doesn't mean it's harder, times the derivative of the inside, which would be 3 plus secant squared. The derivative of tangent is secant squared. You have to memorize that one to know that part. So again, you should be thinking of it as inner and outers. The derivative of tangent something is secant something, or secant squared something. So that's the derivative of the outside part with the inside part plugged in, times by the derivative of the inside part, times 10. Okay, I would like you to try a couple of these, but there's a couple of these that you're not quite ready for. So try the rest of through 15, but skip number 9, skip number 10, and I think the rest you should have a shot at. So 2, 4, 6, 7. So I'll give you 7 minutes for those 7 questions. And then I'll go over all of them quickly, and then we can deep dive on any of them that you disagreed with. But and one of the Khan Academy assignments I'm asking you to practice today is like these questions. So if you are making a lot of mistakes, it's okay. You'll get more chances. Should have about 3 of them done now. Again, don't worry about any simplifying. Trying to get all the pieces that are supposed to be there. Okay, you should have about 2 more to go. Kinda. Do you have too much coffee this morning?
No,
Okay.
I just don't know what to do with the other.
No, you're fine. Okay, there were 7 minutes. So, first thing before I start going through these and telling you what I got, and then you guys can follow up with further questions if you need to, I wanted to point out that if you went to like a calculus formula sheet, or if you looked in like the front cover of our textbook, it does not, well, it does list out all the derivatives you have to memorize and all the integration you have to memorize. Integration's not until next semester. But it does not list them like this. Even though the derivative of e to the x is e to the x, it's not going to list it like that. It's going to say the derivative of e to the u is e to the u times u prime. And so what they're doing there is they're reminding you, hey, don't forget about chain rule. If the derivative of this stuff is not 1, you need to multiply by it. Or even if it is 1, you're technically multiplying by it. So if you opened up a book, the back cover, or front cover, I don't remember, that's why they don't have x's and they have u's, because they want to show chain rule. Okay, so again, I'm just going to do the very fast version of each of these, and I go back over all of them in more detail that you need to. So, derivative of the constant is 0. The derivative of e to something is going to be e to the something times the derivative of that something. So the derivative of 4t plus t to the 7th looks like that. All of that makes up your derivative. Okay, same idea with 8. The derivative of e to something is going to be e to the something times the derivative of the something, which would be sine x. Okay, the reason I had you skip 9 is I have not told you how to take the derivative of an exponential function that's not e to the x. I had you skip number 10 because you don't know how to take the derivative of inverse trig functions. Those are just formulas, but you don't know those right now. Okay, number 11, the derivative of natural log of something is 1 over the something, just like the natural log of x is 1 over x.
Can you scoot up a bit, please, so I can see the answer while you're writing that to the previous ones? All right, thank you.
The derivative of natural log of something is going to be 1 over the something. Oops. Oh well. Times the derivative of that inside stuff, times the derivative of this inside piece. 0 minus 10y plus 3y squared. All of that is its derivative. First part is the same format as what you've been doing. It's just not 1 over x, it's 1 over that mess of stuff, times by the derivative of the inside part. Okay, 12 starts off the same way. It's got natural log, so the derivative of natural log of something is going to be 1 over the something. I don't really care how messy the something is right there, but then I need to multiply by the derivative of this inside part. The derivative of sine is cosine. The derivative of cotangent is negative cosecant squared. Now again, you either need to memorize those trig derivatives, or, which I really think is a terrible idea, but you could change cotangent in the cosine over sine, and you could do the quotient rule, and you could simplify the quotient rule, and after a few minutes you could figure out it's negative cosecant squared. Okay, 13 is probably my favorite, just because I like how they put the 6th power here versus putting the 6th power there. So to start off, the derivative of sine something is going to be cosine of the something, the derivative of the outer part with the inner part plugged in, times the derivative of the inside, 6z to the 5th, plus, now we've got a second term. This one, now, I know why you guys struggle with this one, and it's just because how we do exponents with trig functions. Sine to the 6th, this is the same thing as sine z to the 6th power, like this. So you should have done power rule, bring the power down, lower the power by 1, and in this case the inside was sine z, and the derivative of the inside would be cosine z. All right, for 14, we could bring the power down, lower the power by 1, and then don't forget to multiply by the derivative of the inside, times 7. The derivative of e to something is going to be e to something, but then times the derivative of that something. Sorry?
On number 13, like you wrote 6 sine to the 5, would it not be cosine because you're taking the derivative?
I'm not taking the derivative. So he's asking about this. He's saying this derivative of sine is supposed to be cosine, so why did you leave it sine? Because the first time, again, this is the same thing as this. The first time, you just do the derivative of this big picture. So you bring the power down, lower the power by 1. You leave this stuff the same. I'm not taking the derivative of the inside till the very end in purple. You're taking the derivative of the outside with the inside plugged in. The inside was sine z, the inside's still sine z. You just have to come back and multiply by the derivative of the inside. You're not taking the derivative of the big picture and then taking the derivative of the inside pieces at the same time. That's going to cause you lots of issues. Okay, and then finally, 15. So no chain rule needed here. We can just bring the power down and lower the power by 1. What's being raised to the 7th power is just z, and the derivative of z would be 1, just like the derivative of x is 1, minus the derivative of sine something is going to be the cosine of something. Leave that stuff alone. It stays the same stuff. Then come back and multiply by the derivative of the inside, 2z. Yes?
How do you know when to use chain rule and when's not? Like, how did you know when that was information?
If there's an inside part to it, that's when you're using chain rule. You should always consider it. So like this, the thing being raised to the 7th power is just z. So when I did the power rule, you can think of chain rule if you want to, but the derivative of x is 1, the derivative of z is 1. and multiplying by 1 doesn't do anything. So that's why I didn't have to say anything about chain rule there. But over here, the inside was z squared plus 6, and his derivative is not 1, so you have to multiply by that. But unfortunately, you have to think about chain rule every single question. And anytime you don't think about chain rule, there's a 50-50 shot. You're going to miss it simply from that. So it will get easier with practice, but again, there are some questions like this on one of the Khan Academies, but it's probably not the one I would do first. There's one where you just try to pick out the outer and inner function, making sure that you're looking at the right things first. But is there any of these you'd like me to go more in depth on? Okay, so I do want to put something else on the board that I think you should put on your scratch paper, but number 25 in your binder is going to be your scratch paper for these Khan Academy assignments. And I think I didn't. I listed out what they're on. So one is on just estimating a derivative given a table. I'll give you a hint about that in just a second. One is on using the definition of a derivative. So we talked about that in your notes one time, and we didn't have time to practice it until today. You might want to save those two for the end, or you could do them at first. I don't really have a preference. And then 3 of them are on chain rule. So one is just picking out the inner part and outer part. One is trying to get you to use the chain rule with the table. And one is like the handout we just had out, where it's a function. So you'll need your Chromebooks, and again, you will need some scratch paper, so I'm just asking that you number that as 25. That way, if I need to see it, you can find it.
Don't they turn this in here because I wasn't here yesterday.
No, you can give it to me next time.
All right, thank you.
Also, by numbering your scratch work, if there's something that's consistently giving you problems or some derivative you don't have memorized yet, of course, putting that at the top of your page makes it a lot easier to remember what it was. Okay, I know you guys have the stuff in your binder, but here's a couple of the hints I think you might need on some of these. So the chain rule, picking the outer and inner, I don't think you need much hint there to figure out what they're asking you to do. The one on definition of a derivative, you need to remember the two forms of a derivative. So again, I know you have those in your notes, but I would probably copy them down to your scratch paper so that you remember what you're trying to match it up to. The one on estimating derivatives, my hint there is to think about slope in the slope formula. And one that says chain rule, and you have a table, you probably want to think of this formula of chain rule. Again, it's the exact same thing that we were doing, just a different representation. It's the derivative of the outside part with the inside part plugged in times the derivative of this inside part. It's just kind of a different representation. Again, I want you to do all 5 of these. I don't have a preference in which ones you start off with. Of course, if you get to one that you need help on, it would kind of be nice for you to do that while you're in class so that you can get some help. But you guys have almost 50 minutes. So this is the rest of your classwork, and I guess depending on how well you do, I guess it could end up being a little bit of homework too. Also, we've only done one Khan Academy assignment this year. Remember, I do like to do a bunch of these at the start of the year. I think it's good repetition practice for you. Likewise, I don't want to give all of you a worksheet of 40 of every one of these questions, because not everybody needs to do 40 questions on definition of a derivative. Not everybody needs to do 40 questions on estimating derivative. This way, if you really know what you're doing, you can be done in as little as 4 questions each. But you can try them as many times as you want. There's no reason not to get full credit on this. And when you miss it, instead of just skipping it and continuing on, you should probably click the Get Help button and compare your work to theirs to see what you did differently before you restart. Okay, I'm going to finish putting in these homework assignments, pass those back, and then I will be available the rest of class to help out with whatever you might be struggling with.
do I find the Concat?
It should just pop up. Is this your school account?
I think so. Why? This is the one I'm underclassmen.
Pull up your school email, see if it sent you an email.
Pull up my school email.
Yeah. I think it sends you an email when they get assigned or something. I don't see it there. So something you must not have gotten in the class correctly. Let me see. Looks like you might have signed up using your Gmail, not your school email.
Oh, okay. So how do I do I?
I think if you just go up here, log off, and then sign back in with your Gmail.
Okay.
That's whatever you signed up originally in, so then log back in. And then I'm not sure because I don't ever see it this side, but
It's just the same one.
click up here.
Yeah.
No, I'm just trying to see. Is it 586?
That's my personal email.
Yeah, I know. That's what you signed up for.
Yeah, I guess.
Is that what you just used to sign in Khan Academy?
No.
Okay, that's what I need you to sign in Khan Academy with.
Oh.
That's what Khan Academy has
Well-
as your account email because that's the one you picked.
I don't think my Chromebook will let me sign in with like a I mean, I can just see.
Okay, then I'll have to email you. Go ahead and try it and see.
Yeah, it's blocked.
Okay, then let me. Okay, check your email. I sent you a join code. I might still have to submit the assignments for you though, I'm not sure. Y'all stuff works about as slow as ours does.
What happened to your computer?
Oh,
Something.
nothing. I got it that way.
Oh. Oh, I got it.
Got it. Okay. So click that, and it's going to ask you to sign in, maybe, unless you're already signed in. And that will tie your school email
So
to the correct class.
create a new account. Go ahead.
It's up to you. I would probably just log in if you already have an account. Try that. know you did the first couple.
Yeah, it did. It let me do the first one that showed up for me. I don't know why.
Maybe you did it at home or something. And
I did it in class.
Oh. I don't know. Hopefully this will be the only time you have to.
Oh, here we go. Is this?
There you go. There's the 5 that they're doing.
Thank you.
Okay. I'm gonna pass back these homeworks for you to put back in your binder. But then, as you guys want me to look at some of your work to help, I'm happy to. Make sure I get this back anytime before the test. Something's making your reaction speed slower. Okay, has anybody tried one of these that you're not sure how you're supposed to figure out the answer to? I come around and give you more of a hint than it's already on the board. Okay, so what you gotta do is you gotta look at that.
Yeah.
You gotta think about which one of these two does it look more like. Oh, this one needs limit on there too. That doesn't make sense without a limit. So, which one of those two does that look most like? Does it look more like the standard or the alternate version? Okay, so here's some hints. What do you have in the top left?
Sine of x.
Okay, so there's your function. So if any of the choices talk about just the regular old function, not the derivative, it just depends. So yeah. Functions, not just sine x, so we can't do that. Functions, not just, so that's already narrowed it down to 2 choices. And then A is what you're trying to find the derivative of. So what number do they put here, here, and here? 5, okay. So then they want to know the derivative at pi. So does that narrow it down to 1? Yeah. So you just kind of have to go through it like that.
Okay.
You got to compare it to the forms and then try to extract some hints out of which one it would be. Edward, you finished? Done? Okay, again, please make sure you guys are asking on the stuff that, especially if you're not sure how you're supposed to approach the question. So I can't help you with that once you leave. And again, everybody's going to consider different ones to be the hardest, but I would suspect the one that's called chain rule intro would probably be the hardest one.
So, you have this, did I write this right in terms of what equals
Yep, same thing.
5?
So,
It would be 3. Do
3, and keep that stuff the same. 3 natural log of x.
5.
Okay, now the x, that's not going to the denominator, it's just staying there. So the same way you would take the derivative of x cubed, you would just bring down the 3 and lower it to 2. That's the first part of this. Bring the 3 down, lower the power by 1. But there should be, no, it's not in the denominator. You're trying to do you're mixing two different things up. Just bring the power down and lower the power by 1 first. Leave it natural log of x. Okay, so there's the first part. Now times the derivative of what was inside of all of that.
So 3 over x,
3 wasn't the inside here. This was,
would be x.
it's a natural log of x. All of this was being cubed, so all of that's your inside part. So what's the derivative of natural log of x?
1 over x.
There you go. So times 1 over x. So that looks like that one. That's why that one's going to be the toughest. But carrot. Does anybody know? Hart Howard, 9th grade student. Okay, never mind this one. Of course, you're also welcome to skip around a bit, but you guys are down to about 15 minutes of class, so let me know if there's something I can help with. Make sure you write down these suggestions / notes. It's not that you don't have this in your binder somewhere, but obviously it's a lot more efficient to put it at the top of your page, depending on which one you're looking at. You are still more than welcome to keep working on these until they're due at the start of next class, which would be on Tuesday. A bunch of you guys are already finishing up, but if you don't, just make sure that you do that for homework, please. But those of you that are finished, you've got a few minutes to yourself here. Still nobody that can come around and help? Okay, you guys are down to about 7 minutes here, so you might finish up your thought. If you aren't finished with these and you've got other stuff to do during advisory, you might want to update that you need to finish those up for homework. Again, you can try them as many times as necessary, so no reason not to get 100 on them. So make sure you update your planner if that applies to you. And then I'm not sure about our puzzle. I think I did this one with you yesterday.
Yeah, it was a color one.
Nobody was brave enough to do that one, so.
No,
So today's is also a little bit different, so try not to always show you the same type of stuff. So what do y'all think? What's wrong with these pictures?
Are their lips upside down?
Their eyes and their eyes.
Their lips, their eyes, they look messed up to you?
Yeah.
Huh. That's hard for me to see. Okay, you ready to see the flipped image? So, you're right. It was the eyes and the lips. And if you don't believe those are the same pictures, you just have to turn your head upside down to see it. You guys this quiet all day long? Y'all are easily my quietest class. I'm not complaining, I just... You'll need to get more sleep, I think. We do now have an approximate date for your second assessment too. I put it on the agenda there. So that's always going to be tentative. Could be a class before or a class after, but around the first for y'all. So that's like a week after next Tuesday. That's what I'm aiming for.